Good evening to one and all. This is Gnana Sambandham is going to discuss about my PG project. Then the title of my project is Message Authentication and Source Privacy in Wi-Fi. The main aim of my project is going to have a secure message transmission over the Wi-Fi. So far they are discussed about the secure message transmission only in a wireless sensor networks only. But now I am going to propose a message authentication scheme in a Wi-Fi network because nowadays lot of hackers and anonymous users are present in the Wi-Fi networks too. For this purpose only I had implemented this concept in a Wi-Fi networks so that the anonymous users unable to access the data. Then it is have the high security level because the key transmission has been done through the mailing concept. In existing system, they propose a network security concept in a wireless sensor network. They propose symmetric as well as asymmetric algorithm for the cryptography. In symmetric, they propose a polynomial based algorithm. In asymmetric, they propose a ECC algorithm. In polynomial based algorithm, they proposed the polynomial based in the degree of the polynomial, and it will have the threshold problem because the bulk amount of message cannot be transferred because it will obtain the degree of the polynomial. Within the threshold value only we can able to send the message. More than threshold value we cannot able to send the message. And in ECC algorithm it will not depend upon the threshold value, so more than threshold value we can able to send the message. In proposed system, I had implemented the network security concept in a Wi-Fi networks. So far, the network security concept only depend upon the wireless sensor network. So I am here to propose the network security concept in a Wi-Fi networks. I had implemented the symmetric approach, that is triple DES algorithm. The DES algorithm is the simplest, oldest and the finest algorithm in the symmetric approach. So only I proposed the triple DES algorithm. It is an improved version of the DES algorithm having the three levels in cryptography. That's why it's called the triple DES algorithm. Here the message cannot be corrupted in the Wi-Fi transmission and they have the high data rates. This is my system architecture. First we are going to have the authenticated users and login and node details. First we are going to deploy the nodes, and in the deploying the nodes it is going to see what are the nodes are available in our network, in our Wi-Fi network. That's why it is going to say the each and every node details, and it's going to temporarily store in the database. Why it is temporarily stored means once the transmission is completed it is going to vanish from the database to prevent from the future attacks. And then is going to apply the triple DES algorithm. In this triple DES algorithm it is going to select the data. So in selection of the data it is going to have the apply the triple DES algorithm, and then it is going to encrypt the text and going for the key generation. Atlas is going for the verification node, and it will going to send the encrypted text to the destination. In destination what is going to happen means they are going to have the key signature key from the mail, from the mail, and then they can able to give the security key to the particular encrypted text, and they can able to decrypt the text. This is my use case diagram. So first we are going to have the client and the user server. They are having the destination IP address, security key, the destination mail, and then going to have the signature algorithm. At last they're going to encrypt the messages. Once I encrypt the message, the destination IP address should be given to the client, and that is going to have the decrypted have the original message. And this is the sequence diagram. Here the client going to have the IP address. In the IP address only they are going to see the Wi-Fi network which is going to present here. In the Wi-Fi once they can be able to access the IP address of the particular destination address, they are going to send the messages. Once they send the messages they are going to have the triple DS algorithm, and it will be automatically encrypted the message, and the destination what is going to happen is going to decrypt the messages in the Wi-Fi networks. And these are my modules. First one is authenticate the source node and the message. Second one is key generation. Third one is sender and receiver. Fourth one is node isolation. In first module, authenticate the source node and the message. The user have to select the source node and to provide the source node authentication. The solution should scale for the large number of senders by requiring a reasonable memory and is going to have the authenticated keys. So this is my module diagram, and first we are going to deploy the nodes. What are the nodes are present in a Wi-Fi network, and then we are going to select the source node and then as well as the destination node, and we are going for the anonymous set selection. In anonymous set selection, they are going to block the anonymous user from our Wi-Fi networks, and then they go for the source authentication. At last they go for the data encryption. And the second module, they are going for the key generation. The key generation only, the actual triple DS algorithm has to be occurred here. So here our message should be encrypted as well as the decryption should be done here. And this is our diagram. After the data encryption, it is going to have the key generation and the signature generation algorithm. In key and signature generation algorithm, they are going to encrypt the message. This is my algorithm. In key generation, for encryption process, we have to change our plain text into the ciphertext. First, the plain text should be encrypted by using the key K1, and then the encrypted text should be once again decrypted by using the key K2, and the decrypted text once again encrypted using the key K3. It is going to have a three level of encryption process. That's why it's called as a triple DS algorithm. Here as well as in the decryption process, it is going to um, reverse this process. Our ciphertext is going to decrypted by using the KK3, and then which is decrypted text which is going to once again encrypted by using the key K2, and the encrypted text is once again going to decrypted by using the key K1. So for this, the plain text should be occurred for the destination purposes. And this is a sender and receiver module. Once a node is selected from the sender, it is to be transmitted to the message to a receiver with the encrypted message. In the receiver side, there is going to be a decrypted message by giving the secret key. This is the diagram. The source node which is going to have the encode the message by using the Wi-Fi channel. So through that Wi-Fi medium, it is going to send the message to the receiver. Once the receiver had the node messages, it is only in the format of the ciphertext, and then they are going to decrypt the text by using the key. This key should be sent over to the mailing ID. So from the mail ID, they can able to access the key and they can able to decrypt their own messages. At last, it is the node isolation. This node isolation can isolate from the network or the connection or remove from the network. It will not communicate with other nodes, and it can inform to the all each and every node in the network. The node isolation, it is used to way to prevent the future attacks from the launch by the malicious node, because the node isolation is done only for prevent from the future attacks by the malicious nodes. So this is the diagram. For node isolation is going to remove the networks and it is going to isolate from the networks, and then our database should be vanished here. This is my screenshot. The first year name, the destination name should be presented here, and the IP should be presented here. The signature will be automatically generated, and the security key we have to give the security, for example 123 or ABCD. These are our security key, and we have to give the destination mail ID. Why we are giving this destination mail ID means we have to send the security key to this particular mail ID. For that purpose only we need this mail ID in here, and then here the status of our messages, and here we are going for the actual encrypted message. Here we are going to type as a hello or something, any messages here. This messages should be encrypted, and the encrypted should be displayed in the encryption box. At last we are going to connect the network and we are going to send the messages. And this is my system requirements. Here the hardware requirements are we need the 1 GHz processor, 1 GB RAM and 250 hard disk, GB hard disk, and the standard keyboard and mouse. For software, we need a Windows 7 or XP. The software requirements are operating system. We need like Windows XP or Windows 7, and the platform is MS Visual Studio 2010, and the database is MS SQL 2008, and the front end C Sharp.net. And finally, I conclude this: the message authentication and source privacy in Wi-Fi network scheme has been presented in a secure mega transfer. The original message can be converted into ciphertext in the transmitted into the Wi-Fi network, and it is going to have a secure message transmission in a Wi-Fi networks. In future works, I am going to implement the ECC algorithm, that is a asymmetric approach, and also a mobile environment. For mobile environment, we need a mobile routing configuration. So the message and scheme in the serves privacy in mobile technology. The message can be transmitted from the mobile system to the devices, or for the devices and to the mobile systems. Thank you for watching me.